Alright, students, welcome to Igneous Rocks. Now, igneous rocks are the second main type of rock, and they're formed from molten rock. So odds are if you were thinking of a rock, you were probably thinking of an igneous rock. So if it solidifies from glowing rock goo, that would be an igneous rock. Now, as you might imagine, touching it would probably be very bad as it is thousands of degrees hot. Although you actually could briefly touch the surface. Because the air is so cold and the lava is so hot, there's a kind of film that forms on top, which is almost solidified, and you could touch that. Although I don't recommend being like Anakin here and touching lava. No, Annie! Also, don't go to the dark side. They may have cookies, but they're evil. They're evil, man. Okay, so imagine igneous rocks like you got a big vat of molten sugar here. And as the sugar cools, you can either form like a lollipop or rock candy, depending on how fast you cool it. And that's pretty much igneous rocks in a nutshell. Okay, igneous rocks make up about 90% of all rock on Earth, which should make a lot of sense. After all, here we are on this very, very, very thin layer above this giant pool of molten rock goo. And yes, that's a technical term. Uh, so as that molten rock goo comes up to the surface, towards the crust, it crystallizes, it solidifies into igneous rock. So pretty much we got mostly igneous rock and just a little bit of sedimentary rock on top. Uh, because of this, though, we don't see igneous rock too much at the surface here because most of it's covered by sedimentary rock. Now, to tell if it's an igneous rock, you should see crystals. But unlike the chemical sedimentary rock, these are going to be hard crystals. Generally, you won't be able to scratch it with your fingernail. Also, bubbles will be present. So, as I said, big crystals and bubbles, which you don't see in the other two rock types. Sedimentary rocks just don't have bubbles. And metamorphic rocks, even if there was bubbles originally, well, they would get squished out. Now, let's clear up some misconceptions about igneous rocks. There is lava and then there is magma. And they are two separate things, at least according to science. Lava is the molten rocks that come to the surface of the earth. So if it's spewing out of the volcano, that would be lava. Magma, on the other hand, is molten rock that is below the surface of the earth. So it cools slowly deep within the planet. Note that the longer the cooling time, the larger the crystal will be. This here is the crystal of spodumite found in the Black Hills at the Etta mine. It was 3 feet wide and 36 feet long. So it had a long, long cooling time. Now, extrusive is rocks that are formed from lava that cool quickly on the Earth's surface. So think of volcanoes, and those are extrusive rocks. You can tell that they're extrusive because they cool quickly and have small crystals. Some of them, like obsidian, you can't even tell that it has crystals at all because they're so small. You actually have to look at them under a microscope. Then there are intrusive rocks. This is magma because it's beneath the earth and it cools really slowly. Because it cools really slowly, you have large crystals. So you should be able to see these crystals at the very least and be able to pick them out if it's big below the earth, intrusive rock. Okay? Because the Black Hills are really neat because you can actually see The three rock types relatively close by. So, um, these pink and gray ones are the center of the Black Hills. Basically, there was a bunch of uh, magma that forced its way up through sedimentary rock layers. It made a dome, and then the layers on the top got worn away, revealing the core of the Black Hills, which are these igneous rocks. Intrusive, I might add, igneous rocks. And they're pretty much all the really, really cool stuff besides the racetrack at the Black Hills. So we're talking about like Mount Rushmore, Crazy Horse, um, Harney Peak. They're all the same type of rock, which is the Harney Peak granite, uh, which is an intrusive rock because it cooled slowly under the ground. Okay, so the way I like to remember it is extrusive. Think of external, outside, extrusive. Intrusive, think internal, inside the earth. Okay, and that will tell you the difference between your rocks. Okay, good luck, and I'll see you next time for the last rock type, metamorphic.